Originally called non-rusting steel, it impressed consumers with its no-polish shine, a quality that remains popular today. Stainless steel, even when made from scratch, maintains its shiny and new appearance. Old stainless steel is recycled, transforming discarded sinks, pots, and other items into new products. Tons of scrap steel are melted in a furnace, along with chrome and nickel alloys, to enhance strength and rust resistance. Enormous electrodes heat the mixture until it melts, creating a dramatic display of sparks. After several hours, the molten mix is transferred to a refining furnace, where argon gas and oxygen are introduced to remove impurities. Technicians continuously monitor the temperature and composition, occasionally adding more scrap to fuel the refining process. The molten steel then flows into molds, forming a 75-yard-long ribbon, which is cut into shorter slabs using torches. Workers mark each slab with identification using heat-resistant chalk, and the slabs are moved to another station for further processing. After a break in production, the slabs are reheated to soften them for additional processing. A rusty scale forms on the surface, which workers remove with a pressure wash while keeping the metal hot. The slabs pass through rollers, stretching the steel to over 650 yards, the length of several city blocks. Water sprays cool the steel slightly, maintaining its flexibility for coiling. The steel strip is then tightly coiled like a roll of toilet paper and moved to another station for a hot acid wash to remove any remaining scale. Burners heat the steel and then slowly cool it, relieving stress and softening it for the next steps. The steel is unwound and rolled to the specified thickness, a process that hardens the metal and closes its surface pores, giving it a shiny finish. After one final cleaning, the stainless steel strips are gleaming. The chrome in the steel reacts with oxygen in the air, forming a rust-resistant oxide layer. Finally, rotating knives trim and slit the steel to various widths according to customer requirements. The process is complete, resulting in a brilliantly finished product. Steel forgings are made from scrap iron, including used iron from demolished buildings and old vehicles, as well as leftover new iron from manufacturing. Workers use a large magnet to lift 5 tons of scrap at a time, filling a 25-ton bucket. This scrap is then melted in an electric arc furnace, heated to 650 degrees Celsius by a powerful electric current. Steel production involves 20 main grades and 100 subgrades, achieved by adding metals or non-metallic elements like aluminum, nickel, chromium, vanadium, manganese, carbon, and molybdenum. Fluoride is added to help fuse these materials. Throughout the 3.5-hour melting process, the chemical composition is adjusted to minimize hydrogen, oxygen, nitrogen, and sulfur, which is critical for producing strong steel. The molten metal is then poured into a 45-ton ladle lined with heat-resistant brick. Aluminum and lime are added to counteract oxidation, preventing rust. The metal flows out from the bottom of the ladle into a mold, a process called bottom pouring, which ensures a smoother casting. This forge can create ingots weighing up to 42 tons. After solidifying, the mold is inverted to extract the ingot, which is then reheated to 1,200 degrees Celsius over 12 hours, making it soft enough for shaping. To create large forgings, a forging press is used. This machine, equipped with forming dies, applies thousands of tons of pressure, crushing the ingot against the die. As the steel oxidizes from air exposure, a high-pressure water gun removes rust scales. The ingot often passes through the die several times or through a series of dies, gradually forming the final shape. Metal consists of microscopic crystals, and pressing bends these crystals, destabilizing the structure. Reheating the metal forms new, smaller crystals which strengthen the steel. This is why finished forgings undergo heat treatment in an annealing furnace. Depending on the steel grade, they are heated for 1 or 2 days and then soaked in a water and chemical bath for about 5 hours, enhancing the steel's strength. Finally, the steel forgings are mounted on lathes and milling machines where rust scales are removed, and the forgings are precision machined into industrial parts such as rotors, spindles, and shafts. Some factories prefer to buy forgings in block or bar shapes and machine the parts themselves.